Experiments. So experiments are really great in research. They're useful for explanation and evaluation, and they're basically a process of observing something, right? So we're looking at some sort of intervention, and then we're going to observe how that intervention impacts different things. We're looking at the consequences of that action, and it allows us to test a hypothesis. Now, we all learned about the classic experiment in science class, right? It's got three major components. We have an independent and a dependent variable, pre-testing and post-testing, and experimental and control groups. So our independent variable takes the form of a dichotomous stimulus that's either present or absent. So dichotomous just means two, one or the other, present or absent, okay? It's our cause in our experiment, right? I think that if I light this on fire, it will burn to ashes, okay? So like lighting it on fire is our independent variable. It's either there or not there. It's the cause. Excuse me. Now, our dependent variable is our effects. It depends on the independent variable. Could be physical conditions, social behavior, lots of different things. So generally what's going to happen is our research subjects are going to be measured, they're going to be pre-tested, measured before the intervention, right? Before we introduce our independent variable. Then they're going to get exposed to the independent variable. And then they're going to be post-tested. We're going to see how that independent variable impacted them. Now we're going to have two groups generally, an experimental group and a control group. The experimental group is going to be exposed to the independent variable, whatever treatment we're testing, and the control group should look the same as the experimental group, but they're not going to get the intervention. This lets us determine if the intervention is the cause of the change, if the change in the dependent variable is due to the independent variable. Sorry guys, this is me re-recording the lectures that were all and so I'm on like my fourth one. Okay, so one thing that gets discovered is this thing called the Hawthorne effect, and it comes out of a study, and we find that sometimes when people are part of an experiment or they know they're being observed, they work harder, they become more productive. If I know you're observing me to try to like see how productive I am at work, I'm probably not going to be watching Netflix at my desk, right? I'm probably going to be like working my butt off. And this is what really points to the fact that we do need control groups. So they looked at this study to see if improving working conditions, which in this case was defined as like better lighting, if that improved employee satisfaction and productivity. Okay, workers were responding to more though than just the improved lighting. They're responding to the increased attention they get. Also, generally in an experiment, we don't want you to know if you're being exposed to the treatment or not, right? So think about this in terms of drug controls. If I'm testing out some sort of new prescription medication, everyone's going to get a pill. Some people are going to get a placebo. They're going to get a sugar pill, right? They're going to get exposed to like a dummy independent variable, an independent variable that's empty, okay? Generally, if you're participating in medical research, you don't know if you're getting the treatment. Are you getting the vaccine or are you getting a placebo? Some experiments are what's called double blind, so not only do the subjects not know what they're getting, but the person carrying out the actual piece of the experiment does not know who's getting what. So again, imagine we're doing one of these drug trials and I'm the person handing out pills to everybody every day. I don't know who's getting what pills. All right, so we got our experiment set up. Now we have to think about who's our target population. What's the group the experiment applies to? Okay, and then we have to select members from that group for our experiment. Okay, we want to make sure our experimental group and our control group are as similar as possible. The best way to do this is to randomly assign people to a group, but we can also do matching to do this. Okay. Let me back up for a second. So matching is where I'm going to make pairs of people, one for the experimental group and one for the control group, and instead of randomly assigning people, I'm choosing people that are similar based on the key demographics or characteristics. Oops, wrong one. Okay, random assignment is a central feature of a classical experiment. It ensures us that our experimental and control groups are statistically similar. and it's really the ideal way to carry out an experiment. Now in advance, we might not know what are the key things that I want to match people based on, and that's part of why like randomization is a little bit better. Now when we're doing our experiment, we also want to be careful and make sure that if we're going to try to say one thing causes another, that we pay attention to what's called temporal order. That just means time order, okay? So our cause has to come before our effect. If you guys remind me in class, I'll show you an example of classmate of mine whose dissertation is wildly flawed because he did not pay attention to temporal order. Okay, so if I want to say A causes B, A has to happen first. B cannot happen first. Okay, we also have to be able to prove that like there is a correlation between the two variables, between the cause and effect, and then we also have to be able to show that it's not spurious. So you guys remember you did a discussion board on spuriousness. Relationships that exist between two variables but are actually caused by a third variable, right? So our famous example is how drowning deaths and ice cream consumption increase and decrease at the same rate, but the actual controlling variable there is summer. Now there's a whole series of things that can threaten the validity of our study, right? So first of all, what's happening outside in the world, what's happening historically, that can impact our study. The people involved in our study are constantly growing and changing as people, and that can impact our study. The process of testing and retesting people, right? Every time we're experimenting, even if we're observing, we're impacting our subjects. If we change the measurements in the middle of the process, right? If I'm using different measures of the same variable, or if I'm measuring something and my standards for how I'm measuring it have sort of changed, that can be a problem. There's an issue of statistical regression. Don't worry about what this means too much until you go to grad school and have to take grad statistics. But basically, extreme scores, right? You will, as you have extreme scores, very, very high, very, very low, they eventually regress back to the mean. That's a mathematical concept that we don't have to worry about right now. We want to make sure that we're not biased in how we choose our subjects. And then we also have to think about the fact that subjects are going to drop out, right? And that might change our results. I already mentioned temporal order for you. Also, when you're conducting an experiment, right, maybe I'm doing an experiment where I've got you guys divided into two groups, and half of you are getting some sort of like tutoring or study aid, okay? Or I'm giving you tips, okay? It's possible that during the experiment, you guys start sharing with your friends what those tips are for studying, and they start doing better. So sometimes the treatment diffuses into the control group. It's also important to think about the fact that the control group might be deprived of something of value. So maybe I want to test and see, does this intervention work? Do students do better? But you might be pretty pissed if you find out at the end of the semester that the intervention did work and you were in the control group and you didn't get that advantage, and maybe your grade would have been higher. Sometimes the control group might compensate by working harder. Maybe you guys are like, we're going to prove Spencer wrong and we're going to study our butts off. And then there's also feelings of deprivation amongst the control group. They might give up because they're like, forget it, what am I even doing this for? Now, as we talked about in class, one thing that we're concerned about with most research is whether or not it's generalizable. Can I take what I've learned about this sample, this subgroup, and apply it to the larger group? Right now, if we're doing qualitative research, that might not be applicable, it might not matter, okay? But we want to make sure then that we're accurately measuring what we think we're measuring, and then we also want to think that that's construct validity, right? Like, am I measuring what I say I'm measuring? And then external validity, can I take those findings and apply them to other situations? Now, if you have too small of a sample, this can create an issue for you. It's going to make it hard to find small differences, whereas when you have a large sample, you can find a lot of differences usually. So finding cause and effect relationships depends on your sample size and how big the differences are. So sometimes there's differences, but they're not very meaningful. Now we can take that classic experiment and we can tweak it a little bit. We can tweak the number of experimental and control groups, kind of stimuli we're using, our pre and post test measures, right? So we can tweak this and adapt this. But we can't always do a classical experiment, right? If I want to know if beating your child impacts them long term, I can't just take a bunch of babies when they're born, randomly assign them, and ask some of their moms to beat the crap out of them, right? Like, there's major problems with that, right? Legal problems, ethical problems, right? Unfortunately, guys, we're working in fields where we can't just like experiment on people. So sometimes we look at what's called a quasi-experiment, right? Quasi means to a certain degree, so to a certain degree it's an experiment. We might look at non-equivalent groups or time series designs. So a non-equivalent group is when we can't randomize, okay? So basically this is like matching your subjects. I have a group that's received some treatment and a group that hasn't, and I'm gonna pair subjects based on like demographics or whatever key characteristics are important. Sometimes we're gonna study a cohort. That's a group of people who enter or leave a situation at the same time. Cohorts get talked about a lot in grad school, right? It's the group of people that start together. So we didn't have like class years in my dissertation program, but we have cohorts. So there's a cohort that started a semester before me, and I was in the second cohort. So we were the second group to go through the program. So like everybody who graduates from the police academy at the same time are in a cohort, okay? Cohorts can be a good group to study because they're subjected to similar circumstances. We might look at a time series design, a longitudinal study, something that's happening over a period of time. We might measure it multiple times. It could be an interrupted time series. Maybe a law gets passed or an intervention happens, and I'm going to compare what was going on before and after that. And that might allow me to look at cause and effect. Now, we might also look at things that are case studies, right? And we talked about these in class, and that could be case-oriented research, variable-oriented research, or case studies. And the difference between these are, like, a case study is an in-depth examination of one case or a few cases on a lot of dimensions, okay? So we're going to read that article about that guy in the Canadian military who's breaking into people's homes, stealing their underwear, then he graduates to sexual assault, then he graduates to murder. A case-oriented research is we're looking at a lot of cases to understand a small number of variables. We're looking at just a few issues, but we're going to look at a lot of cases, okay? And variable-oriented research is a lot of variables with just a smaller number of cases. Now, experiments have strengths and weaknesses. Obviously, our ability in an experiment to manipulate our variables makes us like really able to look and see what's playing a role here. We can replicate it, right? Other people can do the same experiment, see if they get the same results, and it's very scientifically rigorous. But lab settings are a little artificial, especially for our fields where we're dealing with people. Now, ethically, we have to think about a lot of things when we're doing experiments, whenever we're doing human subject research. That's why you guys did that human subject research training. And if you were to complete a human subject research, you'd have to submit your proposal to the IRB. I'll show you guys what those look like. Experiments often involve us deceiving our subjects too. We don't always tell our subjects exactly what we're studying, right? They can also be intrusive, right? I can be asking or really like prying into your life, right? And they can cause damage to subjects. So remember we talked about Milgram's experiment, right? And afterwards, it can be really hard for people to be like, oh, even though nobody got hurt, I'm the kind of person who pushed the button,